Hello, I'm Darren Drummond, AtScale Director of Product Management, and welcome to AtScale's latest webinar installment entitled Everything You Need to Know About Big Data and Analytics in the Cloud. Today I'm joined by Matt Aslett, Research Director of the Data Platforms and Analytics channel at 451 Research. Matt has overall responsibility for the data platforms and analytics research coverage, while his primary area of focus includes data management, reporting and analytics, and exploring how the various data platforms and analytics technology sectors are converging in the form of next-generation data platforms. I'm also joined by Saptarshi Mukherjee, Head of Product Marketing, Big Data Analytics, and IoT at Google Cloud. Sap is a technology strategist and product marketing leader with extensive experience in analytics and cloud solutions at both Google and Microsoft. He has led projects in the area of product marketing, product management, ecosystem strategy, and engineering solution development. Welcome, Matt, and welcome, Sap. Thanks for joining us for this webinar. Today we'll discuss what's driving corporate adoption of the cloud. We'll explore the cloud's implications for data management and analytics, how you can make a hybrid environment successful, and discuss what market leader Google is doing to make cloud-based business intelligence and machine learning accessible to the wider market. Before we begin, I'd like to tell you that you can find AtScale on LinkedIn and Twitter. You can also log on to our website and download the latest Big Data Maturity Survey. You can request a demo of AtScale, and you should know that this webinar is being recorded and will be available after the presentation. Finally, if you have any questions, don't wait until the end of the presentation. You can type your questions directly into the application. Finally, and also stick around at the end for live questions and answers. So Matt, let's start with you. Tell us about your research on industry's application of information technology and some of your latest findings.
Thanks, Darren, and yeah, thanks to everyone for joining us on today's webinar. As Darren said, I'll kick things off here talking about sort of analytics in the cloud and pointing at some of the trends and the research that we've put together, seeing how this space is evolving and evolving fairly rapidly. So I'll go into some detail on that. Just briefly before I do, just to introduce you to 451 Research for anybody who's not encountered the company before. So we are an IT research and advisory company. We've got a couple of thousand clients, predominantly technology and service providers, but also corporate advisory, finance, professional services, and IT decision makers. And the last thing I'll point to on this slide is that this 70,000 plus, the next point in terms of the IT professionals, data business users and consumers in our 451 Alliance research community. So these are people, they're not necessarily clients of 451 Research, although many of them work for companies that are, but they are individuals, practitioners, people out there in the field working with technology on a day-to-day basis, as part of their daily working lives. Obviously they're using technology in their home lives as well, and those two increasingly overlapping, and they help shape our view on the market by taking part in surveys and interviews, and we'll share a few of the results of that as we go through this initial set of slides here today. So obviously the context we're talking about here is the cloud, analytics in the cloud, and what we're seeing, generally speaking, is that the cloud is becoming in effect the default business environment. I think if we look back a couple of years ago at our research and our surveys, we saw obviously a lot of workloads either moving to the cloud or being adopted in the cloud, not necessarily sort of mission critical applications, but increasingly we see, it's the business, those mission critical run the business workloads, data and analytics driven, that are being run in the cloud, actually sort of kind of, by default. And there's a couple of reasons for that. I mean, obviously agility is one of those. We see the ability for companies to spin up and down resources as required, and to be very, to rapidly respond to changing and emerging business requirements. Efficiency is obviously another, particularly in terms of sort of reducing the upfront costs in terms of investment in data center and infrastructure facilities as well. I mean, if you look at an individual workload, you can always make arguments one way or the other in terms of whether it's actually cheaper to run in the cloud or not. But certainly in terms of those upfront investments, that's an area where companies are looking to save a lot of money. And thirdly, I think, and increasingly, we almost see here it's a matter of inevitability. Actually, if you look at where the data resides, an increasing volume of data is being stored in the cloud. An increasing volume of data is actually being generated by applications that run in the cloud, and therefore, those analytics and data processing workloads follow the data, and as we'll see, an increasing volume of those workloads actually moving to or being adopted in the cloud in order to take advantage of all that data. And in terms of the sort of number of services we see and public cloud services, I'm not sure that you can see everything on this slide, but I'll highlight the relevant points here. We're looking at sort of which public cloud infrastructure as a service, or we use the term here functions, but kind of services are people currently using. And as I said, if we look back a couple of years ago, data and analytics wouldn't necessarily have been the top of this list. I think we'd have seen it on there somewhere, but perhaps towards the bottom half. What we're seeing is actually data and business analytics coming up second here at 42%. We already see machine learning at 22%, and so and actually, if you look at the complete list here, more than half of them are actually data related. We also see relational databases, NoSQL databases, data warehousing, and real-time streaming data processing. So an increasing volume of the applications, the services that the people and companies are using in a public cloud infrastructure as a service environment are data related. And so therefore, no surprise if we look ahead and we look at what organizations are looking to use, and this year we're asking people what they were planning to adopt in the next year, then we see again data business analytics is near the top of the list. Perhaps no surprise that actually machine learning is at the actual top of the list here. If we look ahead, clearly early stages of adoption, but a lot of companies looking at how they can take advantage of machine learning. And as we said earlier, in terms of the agility, the ease of adoption for new technologies, perhaps no surprise to see machine learning top of that list. So, as we said, data analytics related workloads, an increasingly significant part of what organizations are running in the cloud. And that is going to have a significant impact in terms of where we see that organizations are operating their data processing analytics and business intelligence workloads. If we look at it today, this is obviously a much smaller sample size because we're zeroing in specifically on people using those workloads. But we look at today, more 35% of organizations are running those workloads in a traditional on-premises environment, and obviously that has been historically the default and continues to dominate. But if we look ahead, this is only looking what people are intending to do in 2 years' time. We see that traditional on-premises resources and infrastructure declining from 35% to just 8%, and at the same time sort of the use of infrastructure as a service and platforms as a service increasing from 12% to 27%, software as a service and hosted applications increasing from 11% to 22%. So there is going to be, we're already seeing a shift towards increased use of cloud services for data processing, analytics, and business intelligence workloads, and that's only going to increase, according to what our 451 Alliance respondents tell us. Why are they doing that? So I mentioned sort of more anecdotally earlier why the cloud is becoming the default for business environments. We look at what our respondents tell us. It's reducing IT costs is the top of the list, followed by IT systems agility, and then third here is improved access to new technology resources, capabilities, and features. And that's something, as I said, if we look at machine learning being top of the list for workloads that organizations are looking to deploy in the next couple of years, I think that there's definitely a correlation there. If we look at organizations looking to take advantage of emerging technologies, they're not prevented from doing so on premises, of course, but it's a a lot easier perhaps to do so by taking advantage of cloud services or spinning things up in the cloud and being much more sort of agile and innovative and experimenting using those cloud resources. Now, it's important, a couple of times already, I've kind of tripped over my words a little bit when I've been talking about workloads moving to the cloud. It's something I'm very conscious of. And if we think about migration patterns and the way in which data and analytics processing workloads are being used on the cloud, it is important to think about this, because I think there is, by default, we kind of talk about workloads migrating to the cloud, and we think about a lifting and shifting of existing applications from on-premises to the cloud. Actually, by and large, that's not what we see happening. So there's so you can see precisely the numbers on this chart. But actually, in terms of lift and shift, so migrating applications from on-premises to cloud with minimal changes to the actual application or the architecture, actually we see sort of that with 12.3% of respondents say that's their sort of primary approach to moving specifically sort of mission-critical legacy applications. Actually, we're seeing more organizations are doing what we would call repurchase and shift. So, the actual applications, remain the same, but you're purchasing a newer version, and you're adopting that primarily on premises or software as a service. Again, we see, even more than that in terms of what we would call refactor and shifting, so re-architecting and redesigning the application as part of a move towards, more cloud-native frameworks and deploying in off-premises cloud environments. Of course, what is important to note is that the majority, also not the majority, the biggest proportion of respondents, 44%, so they're actually retaining their existing applications on premises. So we're still in relatively early stages of movement of these workloads, but what they are doing is looking for more modern application and infrastructure architectures. Actually, in terms of just keeping things as they are, sort of retain, I don't know, the numbers just slipped off the chart, sadly, but that's at 11%. So we do about 11% of respondents say they're just, keeping things as they are. And, increasingly, we see that number diminishing all the time. Obviously, there's more proactive and reactive movement towards the cloud. Now, of course, whilst we see that overall general movement to the cloud, it's also true, of course, to say that not all workloads are suitable necessarily for the cloud, or at least there are some concerns or considerations that organizations have in relation to whether a workload is suitable for the cloud. As always, I think every time we've run this kind of or asked this kind of question, you always see security coming out as the number one response. Interestingly, I think more anecdotally, we've seen the attitudes towards security in the cloud changing over the years, and obviously there's been a sort of general recognition that the big cloud providers, with the security tests and hoops that they're being put through by their by their customers, can offer very, very strong security measures, arguably, perhaps in some cases, actually much better than a lot of companies already have in their existing data centers. So it's not to say that security is necessarily an absolute barrier to adoption, but certainly, clearly, it's a concern, and it's absolutely important that organizations look at any kind of workload in relation to any environment, be it on-premises and cloud, and consider the security implications of that. Obviously, compliance and regulatory requirements are related, but in and of themselves do present more of an actual barrier to adoption, particularly in terms of sort of geographical requirements in terms of storing and processing data, and data protection obviously is another point there. I think, as we say, in many cases these are not necessarily complete barriers to adoption, but they're certainly, as we said here, factors contributing to consideration of whether a workload is suitable for deployment in the cloud or not. The other thing, obviously, we see is that it's not just a matter of, moving everything to the public cloud. It's clearly not just a matter of moving everything to a single cloud. And, we talk about multi-cloud. There's talk about hybrid cloud. I'll zero in on what we mean when we talk about that in a second. But what is the important thing here is that we see that it's an increasingly a multi-cloud world deliberately. So a lot of organizations have ended up with multiple cloud providers because they've had different groups or departments within the organization creating different initiatives, a lot of shadow IT, obviously perhaps leading early adoption of the cloud. And so they've kind of, sort of stumbled into the point of having multiple cloud providers. Even when they've done it, deliberately, it may not be sort of as strategically adopted as it could be. But we do see, an increasing number of organizations have multiple cloud environments. Mostly those sort of exist, independently, but an increasing number of them are actually trying to sort of migrate data between those different environments. Now, the fourth category, which we added actually a couple of years ago to our sort of surveys in response to what we saw enterprises doing, is this element of hybrid cloud. So when I know hybrid cloud can mean different things depending on which organizations you're talking to. When we at 451 use the term hybrid cloud, we're talking very specifically about organizations using multiple cloud environments to support the delivery of a single business function, and specifically where the delivery of that function across those different cloud environments is seamless. So it's very much more a strategic decision to use multiple cloud providers, rather than something that organizations have perhaps sort of, stumbled into. And it's as I said, we have sort of added that to our list of responses in response to what we saw that enterprises were doing, and we do see that an increasing number of organizations are taking this approach. So if we look here specifically, again, looking at data processing, analytics, and business intelligence functions, we actually see that over half of the respondents in our latest survey said, yes, they were already using multiple infrastructure environments. So that could be multiple clouds, but obviously on-premises would be in there as well. A further 9% are planning to, and another further 14% are considering it. So it's increasingly, it's not just multi-cloud, it's deliberately a hybrid cloud world. And why are organizations doing that? Well, obviously, there's benefits to be had. There's also challenges. So it's an interesting sort of question to dwell on, I think, in terms of what are the actual reasons that they're deliberately taking this approach. So improving performance and availability is the top response. Also optimizing for cost, perhaps not surprisingly, is the second highest. Obviously, that a little bit easier said than done, but at least that's what they're trying to do. And then thirdly here, I'm not sure if you can see this because some of the wording's got a bit mixed up here. But we're looking at organizations trying to add new functions to existing deployments. And I think that's highly relevant, as we said earlier. If we look at the number of organizations that are looking to add machine learning workloads, in the cloud over the next couple of years. Obviously, machine learning, artificial intelligence can complement an existing application, and we see that's just one example of the way in which organizations are perhaps using a cloud service for a new capability, a new feature of functionality that they can use to complement perhaps an existing application that maybe remains on premises. So there's different approaches, obviously, that organizations can take to that, but that's one of the ones that we're seeing. All in all, when we look at sort of, the range of different sort of capabilities that are available and the concerns of different enterprises of how they pick and choose between vendors, what we see that organizations are increasingly looking for is what we term here sort of a bridge to the cloud. So, analytics users and vendors, both need to prepare for this sort of multi-venue analytics deployment future where data resides across multiple cloud environments as well as on-premises environments, and organizations need to be able to access and process and analyze data from across those different environments. And so this bridge to the cloud, what we're seeing organizations increasingly looking for is that consistency of experience in terms of how, the tools and technologies that can enable them to access and analyze that data. And whether it is on-premises, a private cloud, on-premises, public cloud, hosted private cloud, non-cloud, etc. Now, I want to go back here. So I used this slide before, but specifically wanted to call out a specific trend here. So this was looking at the public cloud functions planned for implementation. We talked about machine learning being top of the list. What's interesting here is we see data and business intelligence at about 18% and data warehouse down much, a bit further down at 12%. And this is reflective of a trend we've been sort of tracking over a number of years. And it's reflective of another important factor, I think, when we look at the way in which organizations are approaching data and analytics in the cloud, which is this concept of the separation of compute and storage. We look at, traditionally, obviously you have your data analytics, BI environment, you have your data warehousing environment, those potentially delivered as literally a single physical stack, or at least, closely interrelated to each other and dependent on one another. If we look at the sort of cloud adoption trends, we've definitely seen that data analytics and BI is nearly said moving to the cloud. As we already said, some of it's moving, some of it's just being deployed in the cloud. But adoption is greater for data analytics and BI in the cloud at the very least than it is for data warehousing in the cloud. Now, there's multiple reasons for that, which we don't necessarily have time to go into now, but one of those is, and it's just one of the reasons, but it is an important one, is the increasing use of other cloud data platforms to support data storage for analysis, and that increasingly being the actual cloud storage systems themselves. And key to this is this concept of data gravity that I mentioned earlier. We see an increasing volume of data is being generated in the cloud, or is at the very least being stored in the cloud in cloud storage. And we see that increasingly, rather than bring that data to the compute for analysis, we see that the analytics capability, the compute being brought to the data. So analyze data with emerging tools and technologies in cloud storage, rather than take it out and spin up some new resources specifically to create a data warehouse or another environment in the cloud specifically just to analyze that data. And there's multiple reasons why organizations are looking to do that. Cost is one of those. Obviously, by separating the query engine from the data layer, companies are able to elastically scale each independently, and so they can then optimize for potentially the lowest cost and the highest performance, and obviously only potentially pay for the compute resources they consume as and when they analyze the data, which is increasingly important as well. With that focus on cost, it's got to wring as many of the benefits as you can out of that. Scalability obviously is another challenge here. Something like, if we look at, say, for example, Hadoop. Hadoop is, of course, scalable. Hadoop running on infrastructure as a service is inherently scalable, but it requires local storage, which can become complex in terms of scaling. In comparison, cloud storage is designed to automatically scale as more data is added without any direct end-user involvement, and so it just, as more data is added, the environment scales to address that. And another key aspect is durability. So specifically in relation to cloud storage, designed to be highly persistent and durable, to the extent that even the best sort of data administrator, highly skilled data administrator, would really struggle to match up to you're talking 7, 8, 9 nines of durability by configuring it themselves, even in a cloud environment. So that's just some of the sort of the key reasons why organizations are looking to take advantage of that data in that cloud environment and analyze that data where it resides, rather than moving out into other environments. So that's just a brief sort of run through of some of the key trends, just to set the agenda here. So just to sum up some of those key takeaways, we do see that the cloud is becoming, in many cases, the default business environment, particularly for new analytics workloads, as more data is produced and stored in the cloud, driven by benefits including agility, efficiency, and modernization. We see that the impact of that is likely to be, or at least our surveys show it will be, a considerable shift in the primary environment used for data processing, analytics, and BI. Our own survey points to sort of a movement from 35% traditional on-premises and 12% public cloud today to only 8% traditional on-premises and 27% public cloud in 2020. Either way, obviously the future is hybrid. Workloads are going to continue for the foreseeable future to be both on premises and in the cloud. So analytics users and vendors, need to prepare for that multi-venue analytics deployments with workloads spread across on-premises non-cloud, on-premises private cloud, infrastructure as a service, software as a service, hosted private cloud, and also hosted non-cloud as well. So with that, I'll thank you very much, for your time here. As was mentioned earlier, we'll be taking questions at the end of the presentations here. So please, if you got any, just contribute those through the screen here, and we'll get to those at the end. But for now, again, I thank you for your time, and I'll hand you back to Darren. Thanks.
Thanks, Matt. I always find it incredibly useful to understand where the industry is going and how they think about solving their problems, because their problems are usually very similar to my problems. So if you want to reach out to Matt, you can do so at matthew.aslett@451research.co. And now I'd like to talk a little bit about how AtScale fits into the mix here. And to do that, we have to understand a little bit about the evolution of data architecture. So let's get into our time machine and imagine the world as it was in the late 1990s or early 2000s. At that time, it was the dawn of the full-service data mart era. So it was not uncommon for different departments or maybe just one company to have their own data warehouse, or perhaps different data warehouses per department. And we saw we saw the invention of the single semantic layer concept, really by business objects. The idea being that you could introduce an intermediate layer between your reporting tool and the underlying data store, and by doing so, you could control the consumption of the data. You could create a view of the data, you could protect it, you could curate it, and you could perform different transformations on it to present it to the audience in the way that they found it useful or how they wanted to consume it. MicroStrategy and Microsoft and IBM also followed, each with their own reporting technology and semantic layer technology. But in this paradigm, it was the IT department that owned the data. And if you wanted to get anything done, you had to go through them, and it was quite frustrating sometimes for the larger business. They couldn't move as quickly as they wanted to, perhaps because they had to get in line behind the other departments. So it was not very much longer where we also learned that data is incredibly valuable, and you shouldn't just throw it away. So the problem with this data mart concept, or one of the problems around the time of the early 2000s, was that in order to make it perform, you had to constrain the size of the data. But it was clear that there was still value to this data, so companies just started storing their data in a data lake. And if they wanted to try to derive some value from that data, they had to do some post-processing on it, add structure to it, move it into a number of data warehouses, essentially turning big data into small data. And that's why on this diagram you see a multiple barrel. You see the lake as representing the data lake, and these multiple barrel diagrams representing the multiple data warehouses. But you still had to interface with all these semantic layers with these established tools. But around the mid to late 2000s, we started to see the rise of the self-service tools, such as Tableau and ClickView, even the Excel pivot table. Each one of these technologies also had their own concept of a semantic layer, where you would take the tool and connect it to the data source. You would abstract away the tables by doing joins and unions in a single layer that were independent from the presentation layer. The consumers of these tools, or the users of these tools, really loved this because it gave them independence from the IT department, and they could get their work done more quickly, independently of all the other departments. But as you can see from the diagram here, all of a sudden now this creates a huge amount of complexity for the enterprise. You have, it was not uncommon for a single enterprise to have many tools involved, and migration projects were really hard because the technologies were not always compatible. So a single enterprise, it was not uncommon for them to have multiple semantic layers, multiple reporting technologies, multiple data warehouses, all being pulled from the same data lake. So AtScale's solution for the problem is to consolidate all of these semantic layers into a single semantic layer and make that semantic layer interoperable with all the tools on the market by speaking both SQL and the language of OLAP, XMLA, and leave the data in place. Don't try to move the data, do the analysis in place. And by doing so, the enterprise is able to realize many benefits, the most obvious of which is complexity reduction. But because you're not moving the data, you also gain a whole bunch of benefits. Because you're leaving the data in place, you don't have to export it, which can take a lot of time, and you lose control of the data. So take, for example, I imagine many people listening to this presentation today have tried to take their Tableau client and attach it to a big data store and in live mode and tried to do some queries or some analysis and simply could not get it to work. So I also imagine that they've then tried to do Tableau data extracts. And that will work up to a point, but extracts, you can only export so much data, and doing so takes a lot of time. And once the data is exported, it ages very quickly. So by having a single semantic layer that doesn't move the data, we eliminate the need to do data extracts, and you can solve the problem of getting different answers to the same question, as is the case if you have multiple extracts floating around, or sort of a jungle of workbooks out there, each with their own concept of a semantic layer embedded inside of each workbook. And then finally, well, not finally, but you can also control security access to the data, change perspectives on it with a single semantic layer, which is much more difficult to do if you've released your data as extracts floating around the world. But in terms of performance, so some of these, the scaling of these technologies, Hadoop, for example, the economics of Hadoop was great in terms of retaining data, bending that cost curve from exponential to linear or even log was really amazing. But that platform really wasn't designed for doing business and intelligence workloads, and that's one of the reasons why you're seeing the rise of these cloud technologies. But no matter what your back-end data platform is, it can always benefit from acceleration. And AtScale provides that through a very clever mechanism or series of mechanisms that have to do with the semantic layer, specifically a combination of the hierarchies in your semantic layer, as well as our smart aggregation system and distributed aggregation functions. So let's imagine, to give you an example, let's imagine a date hierarchy. Almost every enterprise in the world wants to report their data over time. Let's say you're running a website and you're interested in reporting on the sum of sales at the month level. A query comes in, AtScale understands that because you've told AtScale in advance about your desire to report on a time hierarchy, it computes the sum of sales results and sends it back to the client. But in the background, it knows because of the hierarchy you've created, it will aggregate the data so that when the next query comes in asking for the sum of sales over a period of a year, the system doesn't have to go and query your multi-billion row fact table to answer that question. You only have to query the 12-row aggregate table that AtScale created for you to answer that question. So even though AtScale's never seen that query before, you get near cache-like performance from AtScale because of the semantic layer, whereas in most other systems that don't have a semantic layer, that would have been a cache miss, and you would have had to go and scan a multi-billion row fact table to come to that answer. So AtScale it substantially reduces the load on the underlying data platform through this mechanism. And because it is a single semantic layer, It provides a migration path for running on-prem workloads and transitioning into the cloud. And that is exactly what we did for the Home Depot. They started off with an on-prem Hadoop installation, and they used AtScale to model their business and create their reports with Microsoft Excel, talking directly to AtScale. They decided that it was too hard to manage Hadoop, and so they wanted to move the workload to the cloud. They chose Google BigQuery, and so they moved the data to the cloud, and they kept AtScale in place. And their clients, they didn't have to redo their reports. They didn't have to change their model. They simply reconfigured AtScale to point to the new data source in Google BigQuery, and everything else stayed the same. So all the clients had to do was just point to a new AtScale URL, but they were otherwise unaffected, and they were able to enjoy a much lower cost of ownership and management. So AtScale works with Google BigQuery, Amazon Redshift, Microsoft Azure, and on-prem data stores. So AtScale can really be your portal to all your data sources. So at this point, I'd like to pivot to Google's Saptarshi Mukherjee and ask him a few questions about Google's approach to business intelligence and machine learning workloads. Sap, can you talk about how Google is thinking about data analytics in the cloud? What are some of its core principles?
Absolutely. Thanks for asking this. And just to remind everyone, so Google Cloud is the new public cloud venture from Google that started a few years back, but Google has been in the space of data analytics and AI for more than a couple of decades and created some of the most pioneering data analytics technologies like Hadoop or Dremel that later on became Google's serverless data warehouse, BigQuery that you mentioned in your presentation. And we have been thinking about data analytics and AI for a cloud-first world. And we didn't design data systems that were meant to run in on-premise server environment and just ported them to cloud. These were designed for distributed computing. So for the first principle for our data analytics solution is that we are investing in serverless. By serverless, what we mean is the solutions will scale seamlessly on demand without someone need to reconfigure the nodes and the cluster size or think about load balancing, etc. So you bring the data in our cloud and you put the data in systems like BigQuery, and you will immediately start querying the data or visualizing the data using our partner tools such as AtScale and our BI partners. We are also thinking about the comprehensiveness of the platform. We are not just thinking about, hey, can we offer a data warehouse or can we offer another point solution for real time? We are thinking about a stack that is well integrated. So we are offering data warehousing, data lake, real-time streaming data analytics, BI and data visualization tools, and of course, we have data preparation tool, data prep, and AI is one of our secret sauces why customers are coming and embracing our cloud. And talking about AI, it's very important to understand a lot of customers whom I get to talk to and our people, they interact regularly. They're all excited about Google's AI capabilities and they want to understand how to adopt AI for mainstream business process transformation. But building a TensorFlow model or building a cloud machine learning model or applying an API is just like 30 to 40% of the work. The 60% or more of the work in the machine learning lifecycle lies in collecting the right data, processing the right data, preparing the right data, and the tools and services that we offer to enable that workflow from collection or ingestion to storage to processing and then making it available for training ML model is extremely important. We are building an integrated stack that allows customers to do that end-to-end process. And then the fourth, and I think it's very important, is being open and innovative. So we are innovating. Google Research is bringing a lot of projects. We will hear some of the newer announcements that are going to come up in the next few weeks. and we are continuously enhancing our product portfolio. But we remain open as a platform, and we want to make sure that we are supporting open source Apache projects like Apache Hadoop and Spark. They're running on Google Cloud. Apache Beam, which is our open source contribution for streaming data analytics and unified batch processing. We are embracing that. Last month we announced our support for Apache Airflow for managed workflow orchestration in the cloud. So we remain an open platform to essentially enable customers to be portable and have the flexibility in their choice.
Sap, you use the term serverless. What does serverless mean in the context of data analytics?
Yeah, I mean, I think this is a really valid question because serverless is typically used in the context of infrastructure or cloud computing infrastructure. But when we think about serverless, we essentially mean that when you think about data analytics and you look at the left side of this slide and you look at the pie chart, a lot of time is spent in like monitoring and performance tuning and like resource utilization and sometimes like query orchestration. There's a bunch of work that goes in before you actually start analyzing the data and get the insights that you need. In Google BigQuery, for example, when you put the data in the data warehouse, you don't do any of those other data operation type work because Google Cloud is doing that on your behalf, and we are allowing you to just focus on analysis. And that's a complete paradigm shift compared to some of the other data warehouse architectures that exist, including the ones that are running in other clouds, right? And that to us is serverless. Similarly, Dataflow, which is our unified stream and batch data processing service, again, it horizontally scales. So depending on your incoming event stream, the service scales automatically by creating the MapReduce workers, so that you need not need to worry about like, hey, how many clusters do I need? How many nodes do I need in each cluster to manage my workflow? So essentially, you are just focusing on doing the analysis, and then the rest of the system is intelligent enough that it takes care of the data operations and the plumbing side of the work. So that's what serverless is for us. There's no physical infrastructure that's going to hold you back from doing the analysis.
Well, I can't imagine it's magic. Can you provide us some more details on what a serverless architecture looks like?
Yes, absolutely. You're absolutely right. It's not magic. There's a lot of engineering that has gone in from Google to make sure that things work the way we just described it, right? So if you look at BigQuery, I took an example to kind of explain how we implemented this, right? So one is that we have, of course, decoupled storage and compute. So unlike the traditional data warehouses which came from the NPP world or some of the cloud data warehouses that are running, storage and compute are still coupled, right? Here, BigQuery storage is totally different. It's a distributed storage system, highly available and highly durable. And then we have compute, which you can think of, which is the Dremel engine that Google created through its research. Essentially, it's a distributed computing infrastructure that gets provisioned on demand. So if you are firing a query that needs to scan a petabyte data set, the computing infrastructure is provisioned on demand. And when the query results are available to the end user, then this computing infrastructure is taken away. So you need not need to essentially keep running this compute infrastructure. And the other thing that we have done is we have differentiated storage, compute, and the state. So it's very important to understand the state differentiation because we have something called distributed memory shuffle that allows us to make sure that we need not need to be worrying about state preservation when you are moving from one query to the other query. It's dynamically handled by the system. And that gives this whole illusion of, hey, it's completely serverless. There is no server that requires the database administrator or the operator to manage the infrastructure.
So thanks for explaining in more detail the architecture of Google's BigQuery. Seems like this architecture enables almost unlimited on-demand data collection. But This just creates a giant data analysis problem. How is Google addressing this problem area?
Yeah, I mean, I think that's a great point to bring, and as you rightly said, Darren, that a lot of the structured data and semi-structured data our customers are storing in BigQuery, and they're storing like planet scale data. But what about data that are coming from IoT sensors, like video data and audio data, binary large objects, coming at a very high velocity? We offer a data lake in Google Cloud to enable exploratory analytics work on unstructured data types. And Google Cloud Storage is our data lake. The good part is Google Cloud Storage, again, is highly durable and reliable, strongly consistent. The basic thing that we have done with Google Cloud Storage, we have added the capability to query data that is stored in Google Cloud Storage directly from BigQuery using federated query. We have allowed people to build machine learning model by offering TensorFlow connectors to get data from Google Cloud Storage and then train TensorFlow models. Or if you are using Hadoop and Spark for data processing and transformation, you can essentially go ahead and access GCS directly using high-speed connectors and then transform data that is stored in GCS buckets. So GCS is your storage, that's the data lake, but we have the analytics and the data processing layer on top of it that enables analysis on large-scale data sets.
Yeah, so Google has been doing some pioneering work on machine learning. Can you help the audience understand how they can begin their own data analytics and machine learning transformation?
Yes, absolutely. I mean, I think I mentioned this in the beginning of this talk, right? That AI is something that Google is known for, and we have been investing and doing a lot of research, working with a lot of customers to understand newer patterns where AI could be transforming businesses. Every customer is unique, and they have their own sets of problems and challenges. But one thing is consistent is when you think about the ML lifecycle, we typically tend to start thinking from training the model. Like, hey, how do I train the model? How do I hyper-tune the model? How do I test, operationalize, retrain? But a lot of work goes in before you start training a model. Actually, there was a Harvard Business Review article that was published in late 2017 where they said, if your company is not ready with data analytics, it's not ready for AI. And we totally subscribe to that thought process because you need to have the right data transformed, pre-processed, and been ready for you to consume for ML. And we are thinking about a complete end-to-end ML lifecycle. We're not just offering tools that will allow you to build a model, but we are thinking about data preparation. So data prep, visually you can explode data, you can understand anomalies and data patterns, you can do transformation, and all visually through an intelligent ML-based algorithm that runs within data prep. We are offering data processing capability. So it's an end-to-end flow, like how do you ingest data, real-time and batch, and how do you process and make it available for ML. And then, of course, we have Cloud Machine Learning Engine, which is a managed TensorFlow offering. We have pre-trained API models for speech, text, voice, and a bunch of other areas. We have AutoML, which is transfer learning for developers to get started with ML who do not have a lot of traditional data science background. So we are thinking about the space more holistically.
Well, it's definitely a lot of detail. Do you think you can summarize the entire data lifecycle on the Google Cloud?
Yes, absolutely. And if I have to summarize this, there are 4 core areas, or 5 core areas, I would say. One is data ingestion. So if you are a customer, you're experiencing streaming data as well as batch data, you need to analyze both. We offer a Cloud Pub Sub. We have data transfer service that allows people to move data from SaaS applications as well as on-premise systems into Google Cloud. We have a streaming data pipeline engine with Apache Beam, which is the open source implementation, and we have Cloud Dataflow, which is a managed serverless stream and batch processing service. We have Dataproc, which is managed Hadoop and Spark running in our cloud. Once the data is transformed, it's ready to be loaded in a big data warehouse. We have Google BigQuery, our serverless data warehouse. If you're storing unstructured data, you just extract and load and do transformation later, you can use Google Cloud Storage. And then we have downstream advanced analytics services like machine learning, and in Data Studio for visualization, we are working with a lot of partners like AtScale and other BI partners for downstream analytics. And Cloud Composer is our managed workflow orchestration tool for the data lifecycle.
Thanks, Sap. So now we're going to switch to fielding some questions from the general audience. Matt, a question came in, I think, for you. Someone wants to know how many respondents were in your survey.
Oh, okay. Yeah. Well, that depends. I think at the high level, there was actually multiple results from multiple surveys in there. At the highest level, we're talking over 1,000, and then the individual questions it narrows down depending on who those specific questions are aimed at. So yeah, admittedly, if you look at some of the specific questions that are targeting very specifically data. Say, for example, data and analytics users, we get down to a smaller sample. But yeah, some of the initial questions, for example, when we were talking about the migration patterns and the overall sort of approach to adopting the cloud, that was up over 1,000.
Thanks. Always good to know the sample size. Sap, we had another question come in. You mentioned TensorFlow. What is TensorFlow?
Yeah, TensorFlow is an open source machine learning framework. It was primarily designed for data scientists to create advanced deep neural net models when the traditional analytics is not able to help us with predictive analytics solutions. Then people typically use deep neural net models. So complex data types, unstructured data like image analysis or voice or video and all that. DNN enables advanced analysis and machine learning. And TensorFlow allows people to essentially address DNN using that open source framework that exists. It was pioneered by Google, but a lot of companies have adopted TensorFlow. And it's one of the most popular machine learning frameworks out in the market.
Yeah, thank you. So another question came in for a platform as a service, PaaS, which cloud is the best approach? Sap, do you have any thoughts on that?
Yeah, I mean, I think that's a great question, and this IaaS versus SaaS versus PaaS, this evolution in the analytics space is interesting. I will not say which cloud is the best since I represent Google, but I want to. If you look at the space objectively, you need to think about a few areas before you define what's best. If you're thinking about scale, if you're thinking about flexibility and agility in your analytics infrastructure, that hey, my company is growing, I want to come up with new product lines, I want to go and address new customer segments, and I want my analytics infrastructure to be as agile as my business is, you need to think of a serverless approach. And again, as I said earlier, not every data warehouse, as an example, that runs in the cloud was designed for a cloud-first world. So if you are thinking about PaaS, you need to think about, like, is the analytics infrastructure designed for a cloud-first world that's going to meet my need, what I need, right? Scalability, flexibility, cost is a big factor, and I think doing some research will give you some interesting insights here.
Yeah, and just, one of the points that you made earlier, which I'd like to highlight here, is the separation of storage from compute. So especially for smaller enterprises that may not require 24/7 access to all their data, it's really nice to be able to store all your data, but not necessarily have to query all your data constantly. So it's really nice to have the ability to pay for storage and compute separately. I think that's a very compelling feature of Google BigQuery that doesn't exist in some of the other major platform stacks.
Yeah, I totally agree.
Oh, sorry, go ahead. you want to
No, I
finish
was
up on
saying,
that.
I totally agree. The decoupling of storage and compute and state, it has far-reaching impact in terms of just not only the scale but economics of running data analytics infrastructure in the cloud.
So we had sorry, go ahead, Matt.
So yeah, no, I was just going to sort of weigh on that. I think, obviously the definition of the best is always going to be tricky, and definitely I would agree. We look at what our clients do very often. It's very much driven by the specific use case they have, the specific, therefore, set of options they have as in terms of the different services to choose between the available suppliers. Interestingly, we have done some interesting research looking at why organizations choose one cloud provider over another. And what's interesting, if you look at sort of the top 5 attributes they sort of think about in relation to each of the cloud providers, they're more or less sort of the same things. It's things like brand reputation, geographic footprint, performance, strategic vision, innovation, but they're rated in a slightly different order. So there are definitely some nuances in the way in which users look at the different cloud providers, and obviously those get very much more specific when you look at individual services, and as you just alluded to there, very much specifically kind of the architecture through which those are delivered, and there are some real differentiators when you come down to look at specifically the sort of the data processing and analytics products and services. So yeah, very much it's a case of sort of trying those out, figuring out which one is the most appropriate to whatever workload that you have. And again, that's a great advantage of the cloud, that organizations can try out some of these services, relatively efficiently and cheaply.
Yeah, that's a great point. You don't have to make a big CapEx expenditure in order to just try it out. Another question came in. Do you see financial firms leveraging machine learning development and services on the cloud, or are they simply using the ML as IaaS and still developing machine learning models on-prem? Sap, why don't you take the first crack at that one?
Could you please repeat? There was some voice distortion.
Yeah, sure. The question is, do you see financial firms leveraging machine learning development and services on the cloud, or are they simply using the machine learning as IaaS and still developing machine learning models on-prem?
Yeah, I mean, I think that's a great question, and then I will start by saying we are seeing different patterns and different use cases. Let's give some example, right? So we are seeing large banking and financial institutions who are using TensorFlow, right, as their open source implementation for machine learning, and they're using TensorFlow in their private data centers, and they're running ML-based models to do analysis on sensitive data sets on-premise. But we are increasingly seeing a lot of banking and financial institutions are using cloud-based models like cloud machine learning engine, as well as our machine learning APIs like text-to-speech API or image recognition API for doing a lot of work around customer 360 analysis, understanding audience segmentation, working on essentially a lot of sales and marketing related efforts where they're embracing customer service is another area where we are seeing a lot of our banking and financial services customers are using our cloud-based machine learning services to do things like text-to-speech speech-to-text translation to essentially document customer conversations and do further analysis to understand customer sentiment and then offer them personalized services. So a lot of the use case actually, like, are you doing analysis on your core financial data set that are highly governed and restricted by regulatory compliance requirements, then we see a tendency to use the on-premise environment. But a lot of customers are far more open now, and they're using cloud-based services for machine learning purposes.
And how about you, Matt? Do you see any, I suppose financial firms or any other verticals that are making strong moves to the cloud for their core business use cases?
Yeah, absolutely. I mean, I think in relation to machine learning specifically, we've actually got a specific sort of survey around machine learning adoption, which we will be publishing very, very soon in the next couple of days. And certainly when we asked enterprises, which products and services they were using, cloud machine learning services came up very, very high in that, and I think across the board. Obviously, it depends. In some industries, you see more adoption than others, and in fact, down to it's very much down to the individual enterprise. Some are a bit more risk averse than others, and a bit more cautious. But yeah, definitely, as a rule, a lot of adoption of cloud for machine learning. As I said earlier, it enables organizations to experiment, relatively cheaply, and also to potentially add new capabilities to complement existing applications. So I think that's one of the areas that we see organizations looking at those services.
Well, thanks. We've reached the end of the hour, so we're going to have to wrap things up, but I'd like to extend a very warm thank you to Matt Aslett, Research Director of 451 Research, and Saptarshi Mukherjee, Head of Product Marketing, Big Data Analytics, IoT with Google Cloud. Thank you for everyone attending this webinar, and have a great day.
Thank you very much.